A wireless battery charger system is comprised of two parts separated by an air gap: transmit circuit with a transmit coil and receive circuit with a receive coil. The main goal in any wireless power transmitter design is the ability for the transmit circuit to generate a strong field to guarantee delivery of the required receive power under worst-case power transfer conditions. However, it is equally important to avoid thermal and electrical overstress in the receiver during best-case conditions. This is especially important when output power requirements are low and the coupling is great. For example, in a battery charger case, when the battery is fully charged with the receive coil placed close to the transmit coil. My name is Eko Lisuwandi. I'm a design section leader at the power group at Linear Technology. In this video, I'm going to showcase the LTC4125, a new AutoResonant wireless power transmitter IC with integrated full bridge switches capable of delivering up to 5 watts at the receiver. The LTC4125 transmitter IC is designed to pair with one of the various battery charger ICs in Linear Technology's portfolio as the receiver IC. Here in this diagram, it is paired with the LTC4120. The LTC4125 comes with all the features necessary for a simple, powerful, and safe wireless power transmitter circuit. In particular, it has the ability to adjust its output power depending on the receiver load requirement, as well as to detect the presence of a conductive foreign object. As mentioned earlier, the wireless battery charger system needs to generate a strong magnetic field in order to guarantee delivery of power under worst-case power transfer conditions. To meet this goal, the LTC4125 employs our proprietary AutoResonant technology. With this technology, the LTC4125 is able to build a large amplitude AC current in the transmitter coil without the need of a high DC input voltage by matching the full bridge drive frequency to the actual resonant frequency of the series LC network. The LTC4125 also adjusts the pulse width of the waveform across the series LC network by varying the duty cycle of the full bridge switches. By adjusting the duty cycle higher, more current is generated in the series LC network, and therefore more power is available to the receiver load. The LTC4125 performs a periodic sweep of this duty cycle to find the optimum operating condition of the load condition at the receiver. This optimum power point search allows operation tolerant of a large air gap and misalignment while avoiding thermal and electrical overstress to the receiver circuit in all cases. Here, I have the combined LTC4125 transmitter plus LTC4120 receiver demonstration circuit set to charge a single lithium-ion battery at 400 mA. The transmit circuit uses a readily available standard 50 mm Worth coil, while the receiver coil is integrated in a 4-layer printed circuit board with a ferrite shield to improve coupling. The transmit demo circuit includes an 8 LED bar graph, which indicates the input current. The receiver also has an 8 LED bar graph, which indicates the battery charge current. For the purpose of this demo here, I've used series connected diodes to emulate the battery. As I power on the LTC4125 transmit board, the LED bar graph starts blinking every 4 seconds. This wait time between each sweep is easily programmable with an external capacitor. The blinking indicates that the LTC4125 is performing its periodic sweep and not finding any valid receiver. When an LTC4120 board is placed on top of it, you can see that during the next sweep, the LTC4125 detects a valid receiver and maintains the transmit power necessary for the full charge current. The sweep is repeated every 4 seconds to ensure that the load condition, the coupling, or any other system variable has not changed. Notice that the system is quite tolerant to considerable misalignment. When the coils are misaligned significantly, the LTC4125 is able to adjust its field strength to ensure that the LTC4120 receives the full charge current. In the system shown here, up to 2 watts can be transmitted at a distance of up to 12 mm. Another essential feature of any viable wireless power transmit circuit is the ability to detect the presence of a conductive foreign object placed in the magnetic field generated by the transmit coil. This is important to prevent undesirable heating in that foreign object. The AutoResonant technology of the LTC4125 allows a unique method to detect the presence of a conductive foreign object. The graph here contrasts the frequencies of the voltage developed across the transmit coil with and without the presence of a conductive foreign object. By programming a frequency limit via a resistor divider, the LTC4125 stops delivery of any power when this frequency limit is exceeded. Here, I'm using the same LTC4125 transmitter plus LTC4120 receiver demonstration circuit as before. When I insert a conductive foreign object between the two coils, first the object will block some of the field from reaching the receiver. But as soon as a significant enough amount of field is blocked, the LTC4125 recognizes its presence and stops delivering any power at all, ensuring a safe wireless battery charger system. When the foreign object is removed from the field, power delivery resumes normally. This foreign object detection also works when there is no receiver. When the object is placed on the transmit coil, the blinking of the bar graph on the transmit circuit stops, indicating that no power is delivered to the foreign object, not even during the sweep. As soon as the object is removed, the blinking resumes, and power delivery can continue when the valid receiver is again placed on top of the transmit coil. The overall size of the typical LTC4125 application circuit is small, and the application circuit is simple. Most of the features are programmable using either resistors or capacitors. The LTC4125 is a powerful new IC that provides everything required to make a safe, simple, and highly efficient wireless power transmitter. The AutoResonant technology, the optimum power surge, and the conductive foreign object detection via frequency shift is the design of a full-featured wireless power transmitter with excellent distance and alignment tolerance. The LTC4125 is a simple and exceptional choice in a robust wireless power transmitter design. Please visit linear.com for more information. Thank you.